All right, so let us start now. So it's just about me. So like I have been teaching for 20 years and so I mean you can just ignore it. So let's start with the first question, okay? So it says x is 1 over 2 square, 3 square, 4 square, 5 square. And that is expressed as a decimal. So you convert this to a decimal form. So how many distinct non-zero digits will you see in x? And I hope you know that. No calculators, please. Those of you want this PDF or the deck, you just message me on Leland itself, okay? You don't need to share email IDs as of now. You can just message on Leland. I'll message you there, okay, with the attachment. Okay, Nam, yes, okay, that's good. So, what is the approach? How did you do it?
I'm just guessing. Sorry.
Okay, all right. All right, so we have got 1 minute now. We'll discuss this. Okay, so those of you thinking that maybe we'll just work out what this is and we'll actually divide it. Okay, so brute force, you divide. So this is 2 times 3, 6, 6 times 4, 24, 24 times 5 is 120, and then you have to square it. Each number is squared, right? So 120 squared. So we are writing like this: so 2 times 3 times 4 times 5 squared. So it becomes 1 by 120 squared. So it is 1 by 14400, and now you actually divide it. Okay. So that could be a way, obviously, but it is not a very efficient way, as you can see, like it dividing a big number like that, right? So what we do is we do a small different strategy here. See, the twos and the fives, whenever you combine 2 and 5, that gets you 10, right? So that's the principle we'll be using. So here what I do is, see, I get the 2 times 5, okay? 2 times 5 squared, that's there. Then I have 4 squared. Now what is 4 squared? 4 is 2 squared whole squared, right? So 2 raised to the power 4, right? So 2 raised to the power 4, and I don't have enough more 5. So I do is I just introduce a new 5 to the power 4 in this. So that's there, and the 3 square, let it remain as it is. And since I've introduced 5 to the power 4 here, I introduce a 5 to the power 4 there. Okay. Now what happens here is this again becomes 10. So what we have is 5 to the power 4 is how much? 625. If you know it, it's good. If you don't know, then you have to multiply. So 5 squared is 25. If you multiply 25 with 25, that gets you 625 divided by. So that's 10 and again 10. How many times? 6 times. So we have got 10 raised to the power 6. Okay. We leave it as it is, and we have a 9 here. Let us divide 625 by 9. Okay. 625 by 9. So it goes how many times? It will go 6 are 54, then 85, then 9 will go 81, 4 will come, so 40, then 4, and then you see you will keep on getting the 4. So what we have is 69.4444 and so on divided by 10 raised to the power 6, means you have got 6 zeros. What does division by 10 to the power 6 actually result in? You are basically going to just shift this decimal place 6 places left, getting you a lot of zeros. Okay. But then if you realize that this actually just changes the position of the decimal, it does not do anything else. So the question was asking how many distinct non-zero digits will it have? So it just has 6, 9, and 4 as the three digits that you know. Is this okay? Diego, you have said if the numerator ends in 0, okay, there is a number of digits of the number minus 2. I didn't really follow what you meant there. Oh yeah, I think okay. You were thinking of something else most likely. So is the logic clear here? We're trying to avoid the actual division of 144, like 1 divided by 144. I don't want to do that division because that ends up taking a lot of time. The clue was to identify that we have 4 here, so I just introduce a 5 so that I get all the zeros. Then we can just get rid of all that. It's not required. We just have to divide this 625 and 9, and that's it. Right? Okay, let's. Everyone was okay. I hope if have anyone has any questions, please feel free to ask me. Okay. All right. So next, this one. This is permutation combination. This is an actual test question, official question. How do you solve it? But to be able to answer this, you need to have some idea of PNC. Otherwise, it will be difficult. Yes, anyone can. Even if you have not solved it, can share the approach or the method that you are applying to get to the answer. All right. Would you like me to share the approach that we can take? All right. Let me do that. Okay. See, first before I start with this question, answer this. So let's say we have got this 3 by 3 lines, like three horizontal lines and three vertical lines. Can you tell me how many rectangles do you see in this diagram? Rectangles would include squares also. No, not four. See, there are way many. One, two, three, four, five, six, seven, eight, and this entire thing, nine. So there are actually nine. Yes, Nam, you're correct. There are nine of them. Now, without counting, can you tell me how can we get to that nine? Without counting, how can we get to that nine? All right. Okay. Let me then ask you this question: how do you construct a rectangle? So to construct a rectangle, we need two horizontal lines and two vertical lines because these are definitely going to intersect somewhere. And since they will intersect, I'll get a rectangle. So here I have three horizontal lines and I have three vertical. I need to select any two of these three, either these two or these two or these two. In how many ways can I do that? 3C2. From 3 combine 2, 3C2. That's basically three ways actually. If you calculate the using the formula for NCR, NCR is n factorial upon n minus r factorial r factorial. So this will come out to be 3. So you can choose the horizontals in three ways and the verticals in also three ways. And you have your 3 cross 3 9 rectangles that we counted. Right. So in this particular question now, if you look at this from -4 to 5 and you need integers, right? The coordinates should be integers, right? Using these numbers. So like this -4, then -3. You will go on till 0, then 1, and you will go on till 5. So how many are there? There are 1 to 5 on this side, positive numbers, there are 5, and -1 to -4, there are 4 more, so that's 9, and 0 itself, so there are 10. So there are 10 such lines. Okay. Similarly, if you look at the horizontal lines, the y's, so 16 and all the way till 6. So from 6 to 16, there are 11 lines. Okay. Why 11? 16 minus 6 plus 1, because we are counting both. So if you want to find how many rectangles you can make, I am just going to say that, okay, 11C2 and say 10C2. 11C2 is, if you calculate, 55, and 10C2, 45. So you basically have 55 times 45 rectangles in this figure, right? 55 times 45. Leave it at that. We don't need to actually find out the value. 5. This 5C2 is basically n. Sorry, what is it? Yeah. Okay. From NCR, it means from n objects, select R objects. It's a combination principle. From n objects, select R objects. That's combination. Okay. So now, out of these, so let's say you pick one of the rectangles here. Now the question they are saying is, if you look, the right angle triangle PQR has to be constructed such that the right angle is at P, PR is the x-axis along this, PQ is the y-axis along this, and the x-y coordinates of PQR are integers that satisfy this. How many triangles can be constructed? So once we have this rectangle, the triangle in that rectangle can be constructed in 4 ways. Why? With this point as P, we can have one triangle. With this point as P, we can have one triangle. With this point as P, we can have this triangle. With this point as P, we can have this triangle. So we can make P to be any of the 4 corners and get 4 different triangles for every rectangle. And we have got these many rectangles. So how many triangles can you get? This multiplied with 4. So now this 4 you think of as 2 times 2. 55 times 2 makes 110, and 2 times 45 is 90. So you get basically 9900. So there are 9900 triangles that you can create in this shape. Did you follow? For
I think
yeah, yeah.
yes, but can you just tell me the name of the way you calculate that?
I've used
This is trick, right?
no. This is permutation combination,
Okay. Yeah, yeah.
combinatorics. I am typing it down. Okay, permutation, combination, probability. These are like related topics. So probability is something which, like, once you are done with permutation combination, then probability is something like as a follow-on topic. Okay, so these two are the last two topics, like conceptually, like very logical. Very few formula in these, but then it's very logical that what you want to select from how many objects you're selecting. So that's all about essentially about combinations. Okay. Permutations is like one more step ahead than combinations, where you have to, after selecting, also arrange the positions. Okay. If you want to know about more about this topic, then I am going to launch a free lesson only in, let's say, couple of weeks on permutation combination. In fact, covering all the topics. I'm going to launch it in like from the 14th, I think 13th or 14th. You can check my page. You'll find all the lessons listed down. The entire GMAT will be covered, so maybe you can attend those sessions. Okay, just check if your timing works with you, and then maybe you can attend that. All right, so let's move on to the next one. This one, let's skip for now. We can come back to it later if you have time. There are some other good questions also. Would you like to do another one on combinations? Okay, so let's try this. Yeah. What do you do for this one? Anyone got the answer? So what are they asking? That you have to, there's six people, you have to get two groups, okay, of three people each. Okay, you're guessing 50%. Okay. So you need to get six people in two groups of three people each. So two 3% subcommittees. So that's what it is. And they are saying that what percent of all these subcommittees will include M and A together. Okay. That means you want those two guys to be together. So first, let us figure out how many such subcommittees can you make. This is individually not a subcommittee. Okay, what they're trying to say is this and this as a whole is one such subcommittee split that you have got. Okay, for example, if I, let's say, name the people A, B, C, D, E, F, then A, B, C, D, E, F, this split is one such subcommittee. Then A, B, D, C, E, F is one such subcommittee, and so on. So the question, first of all, is how many such can we make? Okay, you are saying they were saying A. Okay, I understand where you made a mistake. Okay, have you done have you done 4C1 divided by 63? Ah, okay, yeah. See, that's what the mistake is. It's not going to be 63. Now, see, if you have A, B, C, D, E, F, and I need to get three people for this group. So I will do 63 because from these six people, I'm just choosing any three, right? So one such selection could have been A, D, E. Then automatically the other three go to the other group B, C, F. Am I right? 63 will get you one such, and like this, you will get many of them, but this is one such selection. But in that 63, you would also get a case where you selected B, C, F, and automatically A, D, E go to the other one. Don't you think that these two are the same? Because the two groups are identical, right? So, since we are dividing it in two equal numbered groups, so your answer will be divided by 2 factorial. Okay. So that's going to be 10. 63 is 20. Divide by 2. So that's 10. So you will get 10 such groups. Just to give it a, I give you a better idea, let's take a smaller sample. Okay. A, B, C, D. If you want to divide this in two equal parts, see the possibilities. A, B and C, D is 1. AC and BD is 1. AD and BC is 1. You won't find anything else. Because the moment you start doing CD and say AB, that we have already considered here. So no need to consider again. But here if you do 4C2, because I'm selecting 2, I'm going to get 6. So the same logic, two identical groups, so divided by 2 factorial. So now you will get 3. That's the 3. So there are 10 such groups. Now the next part of the question is M and A must be together. So if M and A are together, I just need 1/3 person from amongst the remaining 4 people who are left. Okay. So I'll choose that guy in 4C1. So that's 4 ways. And the other 3 will automatically come there in the other group. So I don't need to do any selection for them. So the number of selections where M and A are together is 4. The number of total groups possible are 10. So as a percentage, that is going to be 40%. That is option C. Was this okay, everyone? The 4C1 part is clear because I already have A and M together among the 3. I have 2 already. I just need the third person and I have 4 people left. I can choose any one of those 4. So I just do 4C1. So there are 4 such groups where you will have A, M together. Total 10 such groups. So as a percentage, it's 40%. Right. Now let us now move on to the next question. Let's do something else. Enough of combinatorics. Let us do, yes, some percentages. Okay, this should be more reasonable right now. Maybe those who are just starting off your preparation would find this slightly easier than all this combinatorics and all that. So how do you try this? Yes, others also, please participate. Siddharth, then Sean, SQL, right? I hope I'm pronouncing right. Trevor, then Eka, right? Okay, you are JL only, and Diego, yes. So how do you do this? Let me ask you: do you think that $180 is useful for solving to solve this question? Is it required? Okay, let's see. Make a table. Okay, always when you are solving questions like this, rather than writing values scattered haphazardly, you try to arrange or kind of make a table sort of, or make a visual representation. That okay. So let's, for example, we have two items and we are looking at the cost price and selling price, and there is some relationship between them, right? So item one, item two, cost price, selling price. This way, when you do, everything will be exactly in front of you with all the values and everything. So it will be easy for you to identify. No, not B actually. Let's see. So what do we have first? We see that they're saying the cost price is 180 less than the selling price. There is one information which talks about absolute value difference. Apart from that, everything else is a percentage difference that's mentioned, right? So let us first deal with the percentages, because percentages, when I say a percentage change, it's a 20% more or 20% less, then it is very easy to do, right? If you have X, then 20% more would just mean 1.2 times, or 20% less would just be zero point 0.8 times. Okay, we can express as a multiplier. But if I have absolute difference and I have to write X and X minus 180, this is always more difficult to work with, because there are two different things, addition or subtraction. This is just a single entity, right? Just multiplied. So let us first focus on the percentage changes, or we'll first focus on the ratios, then we'll look at the absolute value differences if there is anything. Okay, so what is, let's skip that for now. The selling price of the former, means the first one, selling price, is 26% more than the cost price of the latter. So if I start with that, let's say the cost price of the latter is C. Okay, we don't know how much it is. Let's see. So the selling price of the first one is 26% more. So it's going to be 126%. So 126% means 1.26 C. Till here, is it fine? 26% higher, so 1.26 C. Right. Now it says the selling price of the first. So it's again 1.260 that we're looking at. So 1.260 is also 5% more. 5% more means it's 105%, means 1.05 of what? The selling price of the other, means of the selling price of the second one. Means we're talking of this value, selling price of the second one. So from here, can I not get the selling price of the second one as 126 upon 105 C? I just divide, right, and adjust the decimal. The good thing is this divides with 21. 6 are and 21 5s are. If you can't observe it in one shot that is 21, first you reduce by 3. Okay. So you'll get 42 and 35 and then reduce by 7 again. So 6 and 5. 6 by 5 is 1.2. Okay. So we have got these two values. So now what's the question? They're asking you the percentage profit on the second cycle, second item, this one. So we don't even need to get this, right? We already know that C has become 1.2 C means there is a 20% profit. So you just mark the answer C. Sorry. Got it, everyone? Now, if you had
Yes.
directly started, sorry, yes, you're saying, please?
Yes. Yes. Yeah.
Yeah. So I'm saying like if you had directly started off with 180 less and say X and X minus 180, things would have become a bit more complicated than this. So as a rule, remember, whenever you come across word problems and you see that there are multiple information given, right? Some information about ratios, some about percentages and stuff like that, and some are how much more, how much less in absolute terms. So use those absolute term information at the end. Always tackle the ratios and the percentage changes and all that stuff first, and then get to that absolute value difference, because then it will find the setting up the equation becomes much more easier. Okay. All right, let's go on to the next one. Okay, mixtures. Yes, this is a favorite topic of GMAT. You get lots of this. Let's try. Okay, you have answered 3 is to 5. Okay, let's see. Oh, okay, I see that. What you have done. You have added 5 plus 1, 6, 7 plus 3, 10. Isn't it? That got you 6 and 10, which is 3 is to 5. But do you think that would happen, though, by the way? The condition was that you have to mix them in equal quantities. So if you are saying 5 to 7, that's 12 parts. And 1 to 3 is just 4 parts. So, yes, correct. Diego, you have got it right. Well done. So, you try making the quantities equal first. That should be the primary goal. Okay, let's see. So, in short, what we are going to do is, so we have iron and copper. in alloy 1 and 2. So this one is 5 and 7, and this is 1 and 3. So if you think it in this way, that 5 units or 5 kg and 7 kg, that makes 12 kg, right? And this is 1 kg and 3 kg, that makes only 4 kg. That's what basically ratio is, right? 1 in 3, and 1 in 3 means out of 4 parts, it's 1 part and 3 parts. So we are looking at 4 parts there and 12 parts there. They are mixed in equal quantities. So we just multiply 3 so that this becomes 12. So this also gets multiplied by 3, and this also gets multiplied by 3. So now iron becomes 5 plus 3, 8. Copper becomes 9 and 7 together, 16. So the final mixture would have them in the ratio 1 to 2. Okay. We don't really need to set up equations and all that stuff. What's the typical name for the grid? See, there is no name for the grid. Okay. So whenever you see, I always use grids. Okay. I mean, whenever I try to represent some information, you will never see me writing stuff that iron is equal to this, copper is equal to this, and stuff. Why am I doing it like this? Because over here, if I write like this, then I can visualize everything in one shot. In one glance, I know everything exactly what is there. So you can think of it as a 2 cross 2 matrix. Okay, 2 by 2 matrix. So where is 2 by 2? You're looking at iron and copper, two elements. You're looking at two alloys, A1 and A2. So as a 2 cross 2 method we are using, 2 cross 2 matrix, and filling up the details there. Lot of questions can be solved like this. Okay, just I mean, if there were three of them, it will become a 3 cross 3. So iron, copper, zinc, let us say. Okay, and you have alloy 1, alloy 2. So we'll just make it like this. My point is try to use graphical representation more than text. Saves time, number one. Okay, representation becomes easy, saves time, and you can visualize the entire thing in one shot. You don't have to search where you had done something, then you have to go back and check again and all that stuff. So that try to consciously modify your way of solving. So it helps. Okay. All right. Let's see another one. Okay. What's this? Yeah. Okay. Let's try this. Time and distance. Okay. Anyone got an answer? All right. Shall I help, or do you need maybe one more minute? Okay, I'll just discuss this. So it says here that this guy John takes 20 minutes to walk 1 kilometer. Okay, so if there is 1 kilometer distance, then this guy John takes 20 minutes and David takes 16 minutes for the same distance, 1 kilometers. Now they're saying that they both participate in a race and David beats John by 240 meters, meaning both started at some point. David reached the end. John could not reach the end. There was a gap of 240 meters and the race stopped there. So David beats John by 240 meters. Can anyone point me one parameter which is the same for both John and David in that race? What is the same for John and David in that race? Yes. Preeti, yes, very good. It's time. No, not length, not the length of race, because clearly David ran 240 more meters, right? John ran less. Yes, Diego, I think, yeah, it is 1.2. Very good. Yes. So the time is the same. So that means in the time David ran this till the end, John could only go till here. Same time. So now here we have 20 and 16, right? We have different times for the same distance. I don't want that, do I? I need to think, I need to see what happens if the time is same. Okay. So what is the same time? What is a multiple of 20 and 16? So we have 80. Let's start with this. If it were 80-minute duration, what would John do? He runs 1 kilometer in 20 minutes. So in a 80-minute duration, which is 4 times, John would cover 4 kilometers. Am I right? And for David, who is going 16 minutes, 1 kilometer in 80 minutes, which is 5 times as much, David would cover 5 kilometers. So that means in a race which was 80 minutes long, okay, David would go 5, John would go 4, and the gap would be 1 kilometer. That's basically what it is. This entire thing is about. But we know in this race, the gap is not 1 kilometer but 240 meters. So 1 has to scale up to 240. So 5 will become how much? 1200 meters. And J would become how much? 4 times 240, 960 meters. See the difference, 960 and 1200, the difference is 240. The question they have asked you is, what is the length of the race? Who decides the length of the race? Whoever finishes first is basically has run the entire length of the race, right? Who finished? So D finished. So D ran how much? 1200 meters. So that's the length of the race. So 1200 meters is 1.2 kilometers. So answer is B. 80 is the LCM, a multiple, common multiple, 80. Now your question is, why did I take 80? Because for me it becomes easy to figure out that what happens in 80 meters. Okay, 80 meters, in that 80 meters, J traveled 4 kilometers and D traveled 5 kilometers. Why could I take 80? Why not 160? It doesn't really matter. I am just taking any multiple of 20 and 16, and I am trying to say that if the time became same, that is the main idea. Okay, if the time were same, why am I taking the time were same? Because they are running a race, and in a race, the time is same for both. So I am trying to figure out in the same time what is the ratio of the distances they cover. So for that I took 80 because it was a convenient number to work with. Right? So I got 5 and 4 and I saw that okay, so it's basically 5, 4 and 1. Now I don't need to bother about that 80. What I was interested in this, that if it is 5, this guy, then the other guy is 4 and the gap would be 1. So if the gap is 240, then it's scaled up 240 times. So just scale up 5 to 240 times, it's 1200. That's the length of the race that you have run. So 1.2 kilometers. Right? So see how I am doing it. Like if I'm drawing diagrams, right? Like drawing lines, then marking 240. I'm not writing much. Okay, I'm just drawing it. So this graphical representation is something which is very helpful when you are doing questions like this where you have a lot of time crunch. Okay, so change your approach or modify your thinking so that you can do it like this. Okay, don't write sentences or statements, or don't do haphazard calculations. Like you do some calculation here, then you do some calculation here, then you don't know like how did you get to that. Then you'll start thinking again that okay, how did I do that. So if you do it in a compact manner, it becomes easier to relate. All right, okay, numbers. Okay, let's try this. Yep, anyone? C. Okay, you're saying 7. Okay, let's see. Others, anyone got the answer? All right, so we need to find the value of y. Okay, so right now x is in x over y ratio is given. So x over y ratio is given. If I multiply the y throughout on and in this inequality, I will get x in terms of y. I don't want that. I want y in terms of x because I want to find y, right? So what I do is I take the reverse of this. So now if I let's say have say I have say x upon y is less than, just saying, okay, just let's say 2 over 3, then if I reverse it, then y over x will become greater than 3 over 2, right? It will also reverse, right? So we are going to do that. Reversing this, I'm now going to get 7 over 4. This less than now becomes greater than y over x. This becomes greater than 13 over 12. Okay. I mean, ideally, I should have written it like this: y over x less than 7 over 4, greater than 13 over 12. Because we usually write the larger number on this right hand side. So now multiply with x throughout. So that gets us y is between 7x by 4 and 13x by 12. Now we just need to divide. Okay, 13 by 12 is 1 point something x. Okay, and this is how much? 4 ones are 4, then 3, 1.75x. Okay, this if you actually divide is going to be 1.083. Okay, 1.083x. You don't need to be so accurate, but it is, you have to understand it is something very close to 1. Now I need to get y to be an integer. Okay, because it's given. So what I do is, and the smallest possible. So that means I cannot make x very large. Okay, so I start with x as 1. Then I'm going to get 1.08. y and 1.75. Not possible, because in this range there is no integer value of y. So I go to the next integer value of x. X has 2. This becomes now 2.16 and 3.5. Yes, there is an integer value of y which is 3 in between these two. So answer is 3. Now that's all. That's all was there in this question. Clear? Everyone got it?
Yes.
What about the others? We have Osman, Alessandro, then Siddharth, Sean, Trevor. You following? This is okay? All right. I guess that okay. Okay. Let's go on. Next, what do we have? Okay, there's again combinations. Okay, we'll come back to that if you're interested. Yeah, this is a good question. Okay, let's see. Data sufficiency on time and distance. Okay, you would have plugged 3 in and seen if it worked with any x. Yeah, that could also be done. Correct. That is also possible. Alessandro, your method is also fine because 3 is the smallest that you have. Yes, anyone? What do you think? B, okay. All right. You think it's A, all right. All right, let's see. Let's draw it. So A and B start from the same place X to another place Y. So this is X, let's say that is Y. After reaching Y, the faster person turns back and returns to X. So kind of this guy, slower one is going. Okay, the faster guy has reached and then turned back. So they are now asking. Now we don't know who is the faster of them. Okay, and who is the slower. We don't know that. But they're asking, is A at least thrice as fast? Means you are saying, is A greater than 3B? Okay, that is the question. Always write down what the question is clearly saying. Is A greater than 3B? Okay, that's what we need to answer. First statement, it says A meets B at a place midway between X and Y. That means when they were going, so this guy is going, this guy has come back. and they are meeting exactly halfway. So now, if you look at this, whoever this person is, let's call that P1, the first person. Let's call that P2, the second person. P1 has covered half of the total distance, d by 2. Okay, but P2 has covered d plus d by 2. So that is 3d over 2. That's the second person. So since the people have started at the same time and they are meeting, their time must be same. Whenever people meet, the time is always same. Okay, provided they start together, obviously. So the time is same. So in the same time, one travels d by 2, the other travels 3d by 2. Right? That means clearly one is 3 times the other. So that means the person 2 and person 1, person 2 is 3 times person 1. Problem is, I don't know who is person 2 and who is person 1. Right? So the question is very specifically asking, is one of them, means specifically is A greater than 3 times B? Okay, specifically that's what they're asking. So if P1 and P2, so if let's say P2 were greater than or equal to, right? That's what they were asking, at least thrice here. So if P2 was A and B was P1, then P2 is 3 times of P1. The answer would be yes. If P1 was A and P2 was B, then the answer would be no. Right? So statement 1 is not sufficient. There's a very interesting thing here, though. A point I hope you have realized already. Let me just remove this 1 minute. If the question was, is ME not at least but more than thrice as fast? Specifically asking more than thrice. Okay, not asking at least thrice, but specifically asking more than thrice. Then statement A would become sufficient, because if P2 was A and P1 was B, then P would actually be exactly thrice. So P2 will no longer be more than thrice. And if it be the other way around, then P1 is one third of P2. That is also not more than thrice. So either way, the answer would have been no. And then statement A would have been sufficient. And this is the type of trap that the GMAT loves to set. Okay. So you have to be very clear about exact thing. So what I was initially done, I had done, at least I had ignored and written just greater than. Okay. And I would have actually ended up saying that A is correct. And then I realized that it is given actually at least. So there is an equal to here. And that creates the difference. Because if it is equal to, then this becomes yes. And the other case becomes no. So statement 1 is not sufficient. Now if I look at statement 2, they're saying if they had started together from X and Y respectively. So that means A and B had started from X and Y respectively. Then they would have met nearer to X. That means B is faster and A is smaller, slower. A is less than B. Question is asking, is A more than thrice? Obviously, the answer is definite no. So 2 is sufficient. So we'll mark our answer B. Have we followed? There was nothing in the question actually. It's just wordplay at in action basically. So if you miss that, at least you have a chance of making a mistake. If you don't realize that 3 is to 1 is there, but then who is 3 and who is 1, that we don't know, right? So then we again have a chance of getting it wrong. Okay, so these are the traps. Okay, you have to be very clear about the data and you have to write down everything. So at least thrice means you write it down. That's what I said. Like whenever you have a question in data sufficiency, always write down the question first and then we'll solve. Right? So this is fine. Let's move on to the next question. Okay, this one. How much time do we have? Okay. What are the other questions we have? All right, let us try this. We have done. We haven't done much on numbers. Let's do this. Number properties. And those who are attending, if you like the session, then do drop in a feedback or review after the lesson. I'll send a link across. So what is this saying? Let's see. So they're asking, is n even? N is at least 2 greater than the product of 6 consecutive positive integers. So 6 consecutive positive integers would be like n, n plus 1, n plus 2, n plus 3, n plus 4, and n plus 5. 6 consecutive positive integers plus something which is could be 2 more or could be 3 more or could be 4 more. Anything is possible. We don't know what it is. Okay. Okay, you are saying A. Okay, let's see. So now this part, when you have 6 consecutive integers, definitely you will have at 3 of them even. Okay. 3 numbers are going to be even and 3 of them are odd. Even if you discard that logic that 3 are even, at least one is even. So that means this definitely is an even number. Product of 6 consecutive positive integers is definitely even. Now, if you add 2 with that, the result remains even. But if you add 3 with that, even plus odd becomes odd. So statement 1 is not sufficient. Could be even, could be odd. Diego, I hope you understood. The result could be even or odd also because it says at least 2 greater. Yes, you missed that. See, this is what these words are very important. Okay, if you miss one word, you will get it wrong. It's that important, and that is how GMAT traps you. Okay, so be very careful with each and every word. So one is gone. Next, the second one is saying n square has no more than 3 factors. So that means you are saying that square of a number has 3 factors or less than 3 factors. Could be 2 factors, could be 1 factor, but not more than 3. So if you square any number, so if you square 2, how many factors does 4 have? You have 1, 2, and 4, 3 factors. If you square 3, 9, you have got 3 factors. If you square 7, 49, 1, 7, 7 square, 3 factors. So any prime squared will always have 3 factors. How do you calculate number of factors? If you remember, it is you add 1 to the exponent for each prime and multiply. So here, if there is only one prime, then 2 plus 1, 3 factors. So 3 factors for a square number implies that n is prime. Okay? Or n is 1. Because then if you have n as 1 and square of 1 is just 1, so 1 has only one factor. Okay? So n could be 1 or any prime. But any prime could also mean n could be 2, 3, 5, 7. 2 is an even prime and the others are odd primes. So statement 2, from that we have n could be even or odd. Again, we don't know for sure. 2 is also not correct. Not sufficient, sorry. 2 is not sufficient. Is that okay, everyone? Till here? That individually it's not going to work? The clue is if you knew that 3 factors for a square number implies it number has to be prime. Only a square of a prime has 3 factors. Any other number, if you square it, will have more than 3 factors. For example, if you try with 4, 16. 16 has 5 factors. 1, 2, 4, 8, and 16. Okay. So now that individually failed, so we'll try to club them together. Well, clubbing them together, see what we have. We know that n is a prime. But we also know that n is at least 2 plus this or more. 2 plus or more. That means this entire thing can definitely not be 2, right? It cannot be 2 because you're already adding the 2 from outside. And then you have this product of 6 positive integers, right? Consecutive. So even if like 0 was allowed, you could have had a chance. But then 6 positive starting from 1. So that's definitely greater than 2. And we are saying it's a prime. So then the prime 2 is not possible anymore. So whatever the prime that we have in statement 2 must be a prime which is much larger, greater than 2. In fact, it is much bigger because after 2 there is no other even prime. So whatever prime it is must be odd. So when you club them together, you definitely get n to be an odd prime, and hence combining both you get the answer. So answer is C. Did that make sense? So first statement says that n could be even or odd. Second statement just says that n is a prime from the two prime or one. When you club the two together, you get that n is a prime which is greater than 2. A prime greater than 2 for sure is an odd prime. Question is asking, is n even or not? So definitely the answer is n is not even. The answer is a unique no, and hence it is sufficient. Got it? So let us move on then to the next question. Let's try this. Good old percentages. Let's see. Everyone, please try. This one should not be very difficult. You should get the answer. Yeah. Anyone? I guess it is A. All right. What about the others? Please chip in with your answers. Doesn't matter if you get them wrong. Give it a shot. E. Yes. Okay. E is correct. You're doing fine. So how do you do it first? Okay, can you tell me how you did that? What's your approach? Do you set up an equation and stuff? Okay, question 7. What was question 7? Let me see. Ah, yes. Okay, good. A table thing, yes. So we have two categories of people, right? One is the volunteer, the other is the organizing committee, OC, let's call that. And we are talking about two things here. One is the number of people, the other is the money. Okay. So we have a 2 cross 2 table. What are they saying? The committee members, so this one, made $1,100 each average. And this was 88% of the total amount raised. Okay, we don't know anything about how many people are there in the committee. So let us move on to the next part of the information, which talks about the numbers. The number of members in the committee was 60%. Now, 60%, if you look at it, is 3/5, 3 over 5 as a fraction, greater than the number of volunteers. So, what I do is I take the volunteers to be 5. See, because I mean, there's just 60 percentage information given, right? We don't really need to know how many exactly there were. If, however, you find that this is little, difficult for you to visualize that how can I just take a random number, then go ahead and take 5x. Just I'm saying avoid taking x. Why? Because you have 3/5, so it is easier to take a fifth of 5x. So they will not get decimals. Okay. So 3/5 of 5x is 3x more. So this becomes 8x. Number of people we have got. Now it says that they contributed $1,100 each. So 8x times 1,100. So that's 8,800x is the money that they raised, which was 88%. So if 88% is 8,800x, then the entire 100% would be 100,000 10,000x. Hence, the remaining, which is 12%, would therefore be 1,200x. So we have got the revenue generated or the money contributed by the volunteers as well. The question is average contribution. So you just divide by the 5. So 1,200x over 5x. X cancels out. That means we can answer the question. X is not important. And this comes out to 240. So that is the fifth option. Is that okay? It's again that table thing that came in very useful, right? Because we see there are two categories of groups of people, and then we have two things that we are working about. We are deciding about them. How much money did they make, and how many people are there? So we make a table of this, a grid. Okay, the grid way of solving, you can call it, if you want to give it a name. Okay. All right, let's move on then. Um, okay, this one we'll skip for now. Yeah. Okay. Let's see this one. Though this is a bit of permutation combination, but still something very logical about this. All right, you're saying B, 278. Yes, very good. Well done. Okay, let's go over this one. So they want you to have 3, 5 exactly in that order together and only once. So 4-digit numbers, you can get the 3 and 5 here or in between or at the end. This was pretty easy to understand that it has to be in these three places only because they have to be together as a string in that order. Okay, grouping. The group has to be there. Now, if it is 3 and 5 here, I can put anything I want in those two places. So this place can be filled with any 10, 0 to 9, 0 to 9, right? The digits. So 10 options for this and again 10 options for this. So that makes 100 such numbers. So you have 100 numbers here. For the second case, however, the starting place cannot be 0. 0 can't be used, then it will not be a 4-digit, it will be a 3-digit number. So there are 9 options here and 10 options here. So that makes up 90. Here it was 100, here it is 90. And the same thing here as well. 9 options there and 10 options there. So 9 times 10. So that's again 90. But now you want this 3 5 to occur exactly once. So when you were writing down all those 100 cases, there would be one case where 3 5 as it is occurs again. So that particular number 3535 has to be discarded. So it will actually be 99 numbers there. And again here, another 3 5 could come. That also has to be discarded. So it will actually be 89 numbers there. So your answer is simply 100 plus 90 plus 90 minus those two numbers. So 280 minus 2, 278 of them. Okay. All right. We are almost out of time, but then maybe we can do, let's see how many which are there. What of questions are there? Okay, let us try this one. We haven't done algebra yet, so let's try one of these. Data sufficiency. Okay, you're saying B. All right. What about the others? Okay, you changed your answer to D. Okay. Anyone else wants to take a shot at this? All right. The answer is D. That's good. So let's write down what the equation is. It's saying 3 books. Let's call that X. Or okay. And 5 pens. Let's call it B and P. Okay. B for books and P for pens. So B is the price of one book. So one book, $B, and one pen, $P. So your equation, this is sufficient. So $30 is sufficient for this. Means this is less than or equal to 30. Okay. We are not saying that it is 30. We are saying less than or equal to. This is given. We know. Question is for 4 is $30 enough? So 4b plus 4p is less than equal to 30 question mark. Yes or no? That's what we need to decide. Statement 1, 3b and 1p is less than or equal to 15. Okay. So we have got two equations. Even though they are inequalities, they are actually of the same nature. So this is the property of inequalities, that if they're of the same nature, both are less than, then you can add them, or both are greater than, you can add them. But if one is the other way around, like one less than and the other is greater than, then you cannot add them. And we are not saying subtract. I mean, you cannot subtract inequalities. Okay, even they're of the same nature. So how to tackle inequalities? Maybe we can, when we do our lessons. Like I'm organizing, as I said, some free lessons. You can just check my profile. So there are, I think, 11 more sessions that are coming up in the next 2 or 3 weeks. So you can attend those. So there we'll discuss how to handle inequalities. But then you cannot subtract inequalities in the sense that you can subtract equations. Okay, but we can add them if they're of the same nature. Just add it. So what do we get? 6b plus 6p less than equal to 45. Divide by 3. 2b plus 2p less than equal to 15. Multiply 2. 4b plus 4p less than equal to 30. That is exactly what we need. So 1 is sufficient. Okay. Second statement. So the given information 3b plus 5p is less than equal to 30. Second one is saying 5b plus 3p is also less than equal to 30. We add them. 8 of each less than equal to 60. We divide by 2, less than equal to 30. Again, we get what we had been asked for. So sufficient. Answer is each statement alone is sufficient. Okay. I hope this was clear. Okay, would you like to do one more? Then we can do this last one. This is a hard question. Okay. Number properties. So only if you know the concepts and stuff, then you will be able to relate to what is being tested. Also, after the session, I'll send you a mail with a link for review. So if you want, you can review. If you like the session and all, then you can put in a review on Leland itself. Okay. You can check my profile if you want to join classes or anything, or you can register for the free sessions as well. Do you know the property of perfect squares related to how many factors a perfect square have? No, you don't have to use any email. Just drop me a text here only, message here only, because I think I am not authorized to like mail you directly with your email. So that's because that will be going outside the Leland, right? So unless, so that is not allowed. So you just drop me a message here only, like after the session is over, right? You can visit my profile and drop me a message there only on Leland itself within the portal. I'll share with you my profile link one. You are saying E, okay? So let me go over this concept here. It says a number n which is a perfect square. So perfect square, what do you mean by perfect square? A perfect square n is anything which has even exponents of its primes, p1 squared, p2 squared, p3 squared, etc. Okay, any even power. So it could be squared, it could be fourth power also, anything. So if that is the case, and remember we had discussed that uh, how can we request for the slides? Okay, so you just go to my profile there, the link I have shared above, and message me directly. I'll share with you the slides. Okay, I'll share the slides with you, the whole deck. Yeah, so as I was saying, so we had discussed that to find the number of factors, we were supposed to, for each prime, whatever the exponent is there, we add 1 to that and multiply. So we'll do 2 plus 1 times 4 plus 1 times again 2 plus 1, etc. Now the point is, if this is a perfect square, these are all going to be even powers. That's what perfect squares mean, right? So if I add 1 to each even number, they are all going to be odd. This will become odd, this will become odd, okay? This will become odd. So product of all odds will remain odd. So the number of distinct factors of n is odd. So you can remember this as a very important property, that for perfect squares, the number of factors is always odd. Okay? So that is the first point. One is true. Second one is saying the sum of the factors. All right, so that maybe we can skip for now and move to the third one. Your third one is again talking about the number of prime factors. So they're saying number of primes is odd. Okay, so to have a perfect square, we can have three prime factors, so that is okay. But we can have also two prime factors. So for example, 2 to the power 4 and 3 to the power 2. This is a perfect square. And there are distinct two prime factors. So the number of prime factors also will be odd is not necessary. So the third statement is false. Okay. The number of prime factors will also be an odd number is not necessary. The number of factors is definitely odd. Number of prime factors could be even or odd. So straight away, this is not correct. This is not correct. Answer has to be either one. I mean, not only one, not only two, because we already know one is correct. So this is also out. Now you have to basically guess between these two. So often this strategy also is very useful. So let's say you are not able to figure out, okay, that what should I mark, or how to tackle the second statement. You can eliminate the third. Now suddenly from five options, where chances of getting it right was 1/5. Now you have suddenly reduced it down to two options. The chances of getting it right is now half. Now you guess and mark and move on. Okay, so reducing the number of incorrect options and then choosing between two of them. How do you choose between two of them? Pick a number and cross check. Okay, pick a number and cross check. For example, a perfect square, let us take a look at 9. Okay, take a look at 9. So we have got 1, 3, and 9. The sum of the factors of n. 1 plus 3 plus 9 is how much? 13. Is it coming out? Yes, it is coming out. Okay, let's go ahead with the gut feeling. So 2 will be correct, and we'll move on with 1 and 2. We are taking a risk here. What is the risk? That 2 might not be always correct. Okay, but then it's worth taking risks sometimes, especially when you're running out of time. So we have marked this and moved on. Now let us try to analyze whether 2 is actually correct or not. Okay, I'm just trying to explain that how you think during an actual test condition. Okay, but now let us try to check. So let's take n to be comprised of only odd primes. Okay, no even numbers. So let's say we have 3 squared, 5 squared, something like that. Okay, so what are all the factors? For 3 squared will be 1, 3, and 9, and for 5 squared will be 1, 5, and 25. And when I make this 3 cross 3 table, okay, I am going to get 9 factors that will come, right? 1 multiplied with 1, 3 with 1, 9 with 1 with 5, 3 with 5, 9 with 5. I'm going to get 9 such numbers, of which all of them are odd. So we are basically going to add 9 odd numbers. 9 odd numbers will be definitely odd. So the sum is odd. So, okay, fine. But what if one of them was 2? So let us say we have the number 2 squared and 3 squared. Okay, one of them is 2. So now we have got 1, 2, and 2 squared with 1, 3, and 3 squared. Just try to see a pattern develop here. Okay, so we again have 9. of which this column is going to be entirely even because these are even numbers. If I had 2 raised to the power 4, there would be two more coming. 2 cube 2 to the power 4, which would also be even. If I have 3 to the power 4, then this will just go on. This will become bigger. 3 cube 3 to the power 4. But this part will still remain even. Which part will be odd? Where you have 1, because 1 is an odd number. Okay. For this, here I have 5 of them, right? Or I will have 3 of them. Why? Because even power means always I'm going to get an odd number of terms on this side. Either I will have 1 3 3 square, or 1 3 3 square 3 cube 3 to the power 4, and so on. 5 odd numbers, the sum is always odd. With that, does not matter how many events you add, the result will be odd. So the sum of the factors will definitely be odd. So 2 is correct, 1 is correct, your answer is C. And that is the main reason behind it. Okay.